Hello guys, my name is Simon Jerry and welcome to another video on ALS Software Engineering Program. Today we'll be looking at recursion, the C recursion. Alright, so the first thing I want you to do is to look at the resources, because this topic is very important. It's very crucial topic. So for recursion, I actually will not want you to limit yourself to the resources you are given here, because this is a very tough topic. And I want you to look into other resources that will be of help. But however, I'm going to explore some examples and do some practical steps to actually make you understand this topic. So first thing I want to do is to open this in a new tab, which is this. So you can see this is a PDF file. It says recursion. So in this file, where I want you to pay attention is this part. It says recursion is a method where the solution to a problem depends on solution to smaller instance of the same problem. Okay. Then the most important definition which I want you to understand here is this. This is the best definition you get. A recursive function is a function that calls itself. Finish. There is no any other definition that is better than this. A recursive function is a function that calls what itself. Underline this, calls itself. Okay, it calls what? Itself. Okay, so if I scroll down, so they are giving us an example of a function that calls itself is a factorial. So what's a factorial? Let's say the factorial of 5, for example, is 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1. That is what a factorial. So you can see these are the programming process, and you arrive at the total of what? 120 for the factorial of what? 5. And if you scroll down, you're going to see some example on factorial. Okay, I'm going to explore most of this example in a few minutes. So, okay, these are just like a basic example, so ensure you look at it and make sure you have a proper understanding of this. So I'm going to go back to the project web, and I want to open this in a new tab. Okay, so if I open this in a new tab, so this is going to a tutorial point, and this is also talking about recursion and the topic factorial. So this is an example. Let me copy this and let us explore this in the online compiler. So I'm going to paste it. And one thing I want you to take note of is this, right? Okay, sorry. I want you to take note of this. Look at the name of the function. It says factorial. And look at what the name of the function again. It says factorial. Look at the body of the function. Right, if you can remember the definition, so it says a function that calls itself. So meaning this function what is calling itself. This is the initial call. This is what the initial call, and from the initial call, the function is calling itself. Now this is the body of the function itself, right? So the function exists in the function. Is a function that calls what itself. But another thing I want you to know, which is very important, is every recursive function has what? A base case. What is a base case? A base case is the endpoint, right? Is a endpoint that checks should I exit this loop, because every recursive function is a continuous loop. It runs forever. So what is going to stop it, like a break, is what? The base case. So you can see the base case here, and it says if I is less than 1. We don't want to calculate anything again. but you can see the calculation here. So what they are doing, I think I have too many right up on the screen. Okay, so what they are doing here is I multiply by I minus 1. So the base case is, if I is less than 1, don't do any calculation again, exit the loop. Okay, exit the recursive function. So if I run this, if I click on run, you can see the factorial of 12 is this, and if I change it to 5, so sorry, yeah, this is 4, so the factorial of 4 will be 4 multiply, this should be a comment, 4 multiplied by 3 multiplied by 2 multiplied by 1. And remember the base case here, it says once I is less than 1, it should what? Return. So you can see 4 multiplied by this multiplied by 2, it should give us what? A total of 24. If we do 3, right, if we remove this part, so 3 times 2 is 6, 6 plus 6 multiplied by 1 should be 6, so our answer should be what? 6. So what if we do 5, right? So if you run this, this is 120, so basically this should be 5 multiplied by what? 4 multiplied by 3 multiplied by 2 multiplied by 1. So this is what? Factorial. And so the takeaway here is a recursive function is a function that calls what? Itself. Then every recursive function has what? A base case. If there is no base case, the recursive function will continue to run forever. So let us look at more example. So I'm going to scroll down on tutorial point. There's another one called Fibonacci series. So for the Fibonacci series, let me just copy this so that we can explore this example on the online compiler. Oh, sorry about that. Let me copy. Control C. Back to my online compiler. I want to wipe out everything. Okay. So the way Fibonacci works is it adds up the previous number. So let me run this and see. So if you look at this, you will see 0 plus 1 is what? 1. Give us the next number, right? 1 plus 2 is what? 3. So 3 plus 5 is what? 8. 8 plus 13 is what? 21. 13 plus 21 will give us what? 34. So that is how the Fibonacci series work. Okay, so now I want you to pay attention here. Let us look at this. You can see this is the name of the function. It's called Fibonacci, right? It's called what? Fibonacci. And this is also the name of the recursion. They are even calling it twice. And this is the body of the function. Okay, so what is basically happening here is the function is calling itself. The function is what? Calling itself. You can see the function is calling itself. So you remember the definition. A recursive function is a function that calls itself. So wherever you see a function that calls itself, that function is called what? A recursive function. Now, another thing that is important, which I've talked to you about, is the base case. Is what? The base case. You can see we have two base cases here, right? We have two base cases here. So the first base case is if I is equals to 0, we don't want to do anything again, just return. And the second one is if I is equals to 1, don't do anything again, just return. So like I said, if a recursive function did not have a base case, it will continue to run forever, and that will lead to crash of systems and a lot of troubles. So it is a must that every recursive function should have what? A base case. Alright, so with this understanding, I hope you've catch the full understanding of how recursive function works. However, I won't want you to limit yourself to the resources that is here. You can do a lot of research, a lot of study, play around with the code to actually have a proper understanding of how it works. So that is all for this. I'm going to see you in the quiz section. Welcome to the quiz section. So the question O, which is #O, it says, what does this code print? You can look at it. So I will actually advise you can actually read this and hang it in your memory. You can just copy it and run it on the online compiler to have your results. So but for me, you can see the answer is what? Here. Okay, so if you scroll down, right, the question 1 of the quiz section, you see, what does this code print? So like I said, you can always copy and run on the online compiler, and when I did, this was what I get, right? Okay, so if you scroll down to 2, so for this, the correct answer is what? Is this. So I'm going to scroll down for question 3, right? If you look at it closely, you see the correct answer is what? This. Then for question 4, it says, what does this code print? If you copy and run on a compiler, this is what you get. This is the correct answer. So we are done with the quiz section. I'll see you in the tags section. Alright guys, welcome to the task section, and the first thing you want to do is to log into your cloud server. So I'm going to hover my mouse on this window, right click and open a new tab. I want to do SSH to my cloud server. So what I will do here, this is my terminal, my local terminal, and this is the web. This is my credentials to do SSH. So what I will do is to click on this button and copy my SSH link, paste it on my terminal, press enter. It's going to prompt me for a password, so I'll quickly copy my password and I'll paste that here. Enter. Okay, I'm currently in my cloud server, so I want to locate my project directory. So mine is located at root, example, ALS, low level programming. So if I do LX, these are the list of what I have here. Okay, so if we go back to the web, the first thing you want to note here is what you should be in this folder, which is the GitHub repository, and you want to create this folder, right, which is 0x008 recursion. So I'm going to copy the directory name and create that directory. Then navigate into that directory. So if I do LX, you can see the directory is empty. But if you go back to the browser and you scroll up, you will see it says a readme.md file at the root of the folder of the project is mandatory. So I will go back and create a readme file. Then it should not be empty. So I for insert, I'll just write anything. You can write anything related to your own project. Okay, I'm going to save that. So you can see I now have what my readme.md file. So if you look at the general instruction again, which is the general requirement, it says the prototype of all the functions and the prototype of _pucha should be included in the file main.h. So we want to do that straight away. So all you need to do is to create your file, which is main.h. Enter, insert. So you can see these are the prototype. So you can either include all of them now at once, or you can just go ahead and put it one by one, which is when you're working on this project, you put this prototype and put it in this file. Then when you're done with this project, you move to the next one. But to me, I prefer I will just add everything at a time so that I do not need to visit that file again. So I already have my header file, so I'm going to escape this. You can see there is no main.h file here. Let me copy the one I have. It should be ALX, low level programming language, and to locate the folder OX0x08, and I want to copy the file, which is main.h. It should not be capital letter. main.what-ish in the current directory. So if you look at mine, so you need to check if the file is there. Definitely is there. You can see the file is there, main.h, and you can see the content of the file, which is main.h, but there's something missing here. Let me just do that quickly. So I'm going to modify my main.h file, main.h. So here you can see my prototype are not protected, so I need to do that. So I have pressed I to insert, and next I want to do is to put hash after the hash. So I will now do if index, then main_ish. Okay, so in the next line I want to do define. Sorry, this should be small letter. Define, and in this define it should be what? main_h. Give some space, and at the bottom I want to go to the bottom, at the bottom here. So we want to do and if rather, and if. Okay, there should be some space. This is enough. Sorry, at the top I made a mistake. This, instead of X, it should be F. Okay, so writing it like this, the prototype has been protected. So I want to exit this file and check if Betty will yell at us. So Betty main.ish. Okay, so the file is good. So the next thing we want to do is to look at our requirements. And we can see we need a file. Why? We need a file which is _pucha. So you need to create that file. So we already have this in our previous work. So what we'll just do is to copy it from OX07, I believe it's there, which is 0x07 underscore pucha. Copy it in the current directory. Okay, so if you check now, you can see we now have what main.h and underscore pucha, and this is the content of the underscore pucha. You can see here is it. Okay, so I'm going to clear my console, and the next thing we want to do is to read the requirement, right, of tag 0. So it says write a function that prints a string followed by what, a new line. This is the prototype. So we've added the prototype already in the file main.h. So next thing we want to do is to write our solution, and the name of the file to hold our solution is 0 put underscore recursion. So this is what I'll do. So I'll just copy that, right, from what I have officially submitted. You can see. So the name of the file should be 0 dash what. I'm going to copy that in the current directory. So if you check now, you see I now have that file, and this is my solution. Okay, so you need to write yours. This is my solution. Okay, sorry, I copied the wrong one. I copied the executable file, so let me just delete it quickly. Sorry about that. Okay, and let me copy the original one. So this should be .c. Good. So you can see the name of the file match what we are looking for. So this is 0 dash put underscore recursion.c. So after doing this, the next thing you want to do is to test your file, and you've given a test file already. So all you need to do is to copy the content of the test file, and you want to create that test file. So look, note the name. This is what, this is 0-main.h. so we want to create that file 0-main what .c rather .c. I for insert, right click to paste. So this is what your test file. So if you check now, you are good to go to test the tag 0. So we have the main.h, which is the test file. We have the 0-put underscore recursion, which is the solution of tag 0, and we have the file main.h, which holds all the prototype, and we have underscore pucha, which does the printing. We also have the readme.md. So the next thing we want to do is to test our file. To test your file, what you need to do is to copy the gcc command. So from here to here, Ctrl C to copy, then run this command. So it has been pasted on my console, and if I press enter, if there is no error, it means everything is okay. So you want to check, you can see there is a new file here. There is what, a new file here, and this file is executable, right? So we want to run that file, enter. So it says the result it gave us is put with what, recursion. And if you look at the results it prints here, it's actually the same thing with what we got. So this shows you have successfully completed tag 0. So the next thing you want to do is to do your git add, git commit done with tags 0, and do your git push. Okay, mine did not have an upstream, that's why it's not going. This is for this is just an example. Okay, so you are actually done with task 0. So the next thing you want to do is to go to the next task. So in the next task, you can see it says write a function that print a string in what? Reverse. Okay, most times if you look at even the test file you're given, it gives you some kind of idea, right? Like the name of what the function should be, the name of the function and the rest and so on. You can see if there's a parameter or not. So but let us write our solution, right? So the name of the solution should be 1-print underscore rev underscore recursion. So we need that file. So you can write yours. You can write yours by running this command vim, or depending on the editor you are using. I'm actually using the vim, so the vim followed by the name of the file to create that file. But for me, I've already written that file, so I'll just copy the name of that file. Okay, so I want to copy that file, and the file should be 1-print.c in the current directories. So if you check, you can see I now have that file here, and you can see the contents of the file. So the next thing you want to do is to check if what you've written is in compliance with Betty. So Betty followed by the name of the file, enter. Yes, no complaint, so it means everything is okay. Next thing you want to do is to create your test file. So if you go to on the web, on the project page, you will see there is a test file here. The name of the file is 1-main.c. So all you want to do is to copy the content of the test file, Ctrl C, and you go back to the browser. So you do your editor, vim, note the name of the test file, which is 1-main.c. You enter. I for insert, then paste. Okay, you are done with your test file. No, this is a test file, and you don't need to do Betty on this, because this is just a test file. It doesn't bother. They don't actually take this into consideration, because most time Betty might complain about this file. You can see it's complaining, but necessarily we don't need to fix anything here. It's not necessary. It's only your main file that holds your solution you should show concern about. So you should fix any error, any Betty error there. So alright, the next thing we want to do is to run our file. We want to test our file and see if we have the same result as this. So what we'll do is to copy the GCC command, Ctrl C, copy, right click, paste, enter. If there is no error, it means everything is good, just like mine. You can see no error. But if you check the console using LX, you see there's a new file, an executable file, which is 1-print underscore rev underscore recursion this. So the next thing we want to do is to run this file and see if we have the same result. So I want to do 1-this, enter. So if you look at the result of mine and compare with what you are seeing here, this is the same. This is what? The same. So this shows you've done it correctly. Then the next thing you want to do is to do your git add, git commit, done with tax 1, then your git push. Okay, so I'm not going to push. Then once you've done this, you should should go to your web. I mean, click on this check your code, and you want to start testing. So I believe everything should be good when you've done the writing. You should see everything green like this. You can see mine, everything is green, and you can see the message at the top. It says congratulations, all tests passes successfully. So you want to close and move to the next task. But I think this 2 example is okay. So basically you can follow the same pattern. They're actually the same pattern, so you just need to follow along and create your solution. But however, I'm going to drop a link to my GitHub repository for this project, so just make sure you follow along. Do not do copy and paste, as you may not meet the requirement. You need to type it yourself. Even though it's the same code, type it yourself. So before I go, I need to show you how your project will look like. Okay, let me clear this, and okay, let me remove this project, which is -x-recursion. I want to remove everything. Okay, then I want to copy the project itself. Okay, so I'm gonna go back and remove this. I want to copy file. I want to copy all the projects, the project directory itself. Okay, then copy it recursively. So if we check, you can see the project is here. This is its recursion, and we want to list what we have in that project. You can see, so at the end of everything, this is how your project will look like. You can see it has the executive. Make sure you execute the file and run it. Everything should be good. So that is all for this video. I'll see you in another video. Thank you very much for watching.